Okay, let's continue with question 11. So consider the equation 2 to x equals to mx plus c, where m and c are real constants, which the following statements is or are true. Okay, so the classic if and only if question, right? So we need to have really rigorous logic here. Okay, so let's look at 1. So the equation has a negative real solution only if c is greater or equal to 1. Okay, so how about this? Let's just draw 2 to the x first. That makes life slightly easier. So, well, the y-intercept is 1, right? We all know that. Okay, so this is y equals to 2 to the x. Now, let's say, so it says only if, right? So if we find a counterexample, then it's fine, right? Okay, so can we find a counterexample such that there's a negative real solution, but c is less than or equal to 1? Well, you just do something like this, right? Then, then the thing is wrong, right? Because for this one, c is less than 1. C is less than 1, right? So, and the equation also has a negative real solution here, right? Whatever x value this is. Okay, so 1 is wrong. Good. 2. The equation has 2 distinct real solutions if c is greater than 1. Okay, so let's try. Well, if I have c greater than 1, what if I draw something like this? Well, are there 2 distinct real solutions? No. Right? Not quite. There's only 1 here. Okay, so 2 is also wrong, right? I just find counterexamples. Okay, 3. The equation has 2 distinct positive, okay, this is a really important word, positive real solutions, if and only if c is less than or equal to 1. Okay, so now I need 2 distinct positive real solutions. So imagine that my line starts, for c greater than 1, suppose, right? Okay, now we know that if there's a negative gradient, then there's no way, right? There's only 1 solution. Okay, now, would it be possible for you to draw, a line, a positive gradient line, such that it has 2 distinct positive real solutions? Not quite, it seems like, right? Not quite. Okay, so that means that c has to be less than or equal to 1. Okay, so this way implies this. Okay, so if the equation has 2 distinct positive real solutions, that implies c is less than or equal to 1. Okay, so the only if direction is what's the word? Satisfied. Okay, now we go the other way, right? Is it true? Does c less than or equal to 1 imply that the equation has 2 distinct positive real solutions? Okay, well, if I do c is less than or equal to 1, I do this. Well, then there's only 1 solution, right? So that's no good, right? So only one of the direction works, okay? Only one of the direction works. Okay, so that means that 3 is no good as well, okay? So, none of them. A is the answer.